Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about some of the common terms that are found in this idea of set. So first, let's start off with the definition of a finite set. When you have a finite set, it means that you will be able to count the number of elements in that particular set. For example, here we have set A, and set A consists of tiger, lion, puma, cheetah, and so on. And you'll be able to count all the elements inside set A, and the number of elements in A is going to be 6. So that is an example of a finite set because you are able to get the exact number of elements. Now for set B, this is a set of small alphabets, and we have A, B, C, and it continuously goes on until Z. And if you count the number of alphabets there are in this set, you will see that the number of elements in set B is equal to 26. So as long as you are able to count the number of elements, then we will say that these are examples of finite set. Next is infinite set. So opposite to the idea of finite set, an infinite set is a situation where in principle you are unable to count the number of elements. For example, here we have set C. C is a set of negative numbers, -1, -2, -3, and here it means the pattern goes on accordingly. For example, you will have -4, -5, -6, and so on until infinity, and by this you will be able to get the number of elements for set C, and so we say that set C is an infinite set. So similarly, if you have set D, where D is a set of prime numbers, and we know that prime number begins from 2, so we have 3, 5, 7, 11, 13, and it goes on infinitely. So in this case, there is impossible for you to get the number of elements, and therefore this is an example of infinite set. Okay, let's move on to the next definition, which is equal sets. Now, if you have 2 or more sets that have the exact same element, so it doesn't matter if they are being ordered differently. So ordered differently is not a problem here, so it doesn't matter if the order is different. Then we will say that the two sets here are equal. So for example, here we have set A. So A is 2, 4, 6, 8, and 10. And we've got another set here, set B. So we've got 2 and 2, 4 and 4, 6 and 6, 8 and 8, 10 and 10. So they have the exact same element, but they are being ordered differently. Again, the order doesn't matter, and we will say that the two sets here, A and B, are equal. Now let's move on to the definition of subset. So if all the elements in set A, so here is the keyword, all elements in set A are contained in set B, then we will say that set A is a subset of set B. So what's the keyword here again? The keyword here is the word all elements. So the all elements in A must be in B. So if that is the case, we will say that set A is a subset of set B. And this statement here can be mathematically represented by this symbol here. So we say that A is a subset of set B. So this is the symbol for subset, or you can also say that B is a superset of A. So this is superset of A. Okay, so now let's look at a simple example. Here, suppose that we have this set, so set A and set B over here. Now let's see whether A is a subset of B or not. So here we have elements. The first element here is 2, so you can see there's 2 here, and then we've got 4, so 4 is somewhere here. We've got 6, 6 is somewhere there. We've got 8, 8 is over here, and we've got 10, 10 is somewhere here. So we can see clearly that we've got all elements in A, so all of the elements in A are contained in B, so they are given in B. So therefore, in this case, A is clearly a subset of B. Now, if let's say I have another set which says C, C is a subset, C is a set where you have the following elements, like maybe 0, 2, 4, 6. So now if we try to see whether, now let's try to see whether C is a subset of B or not. So is C a subset of B? Well, you can clearly see that 2 is given in B, 4 is also given in B, 6 is also given in B, but 0 here is not in B. So in this case, not all elements of C are in B. So remember, whenever we want to say something is a subset of something else, all of the elements in that set has to be contained in another set, yeah? So in this case, is C a subset of B? So the answer here is no, because 0 here is an element that is not given in set B. Okay, so I hope that is clear so far. And I think what I'm going to do next is I'm going just to stop here, and I'm going to continue in the next video, and I'm going to talk about the idea of empty set and cardinality of a set. Alright, thank you very much for watching.